Hello everyone, welcome to the lecture on discrete mathematical structures. In this lecture video, we'll be discussing about introduction to graph theory, what is graph and types of graphs. First, I will start with the definition for directed graph. A directed graph is also called a digraph. It's a pair of elements V, E. So where V is a non-empty set and E is a set of ordered pairs of elements taken from the non-empty set V. For a directed graph V, E, the elements of V are called vertices, are also called points or nodes, and the elements of E are called directed edges. The set V will be in turn called as vertex set and the set E will be called as an directed edge set. To define this vertex set and directed edge set, I'll be taking a graph having 4 vertices as shown here. So we can see here this graph consisting of 4 vertices A, B, C, D. So now grouping this vertices A, B, C, D in a parenthesis will be called as a vertex set and it is denoted by the notation capital V. Similarly, we can observe that there is an edge between each vertex here, and between AB we are having one edge, between AC we are having one more edge, and between CD we are having one more edge. So now grouping all these edges in a parenthesis will be called as an edge set and it is denoted by the notation capital E. That is, the vertex set will be equal to V is equal to A, B, C, D, and the edge set will be equal to E is equal to AB, CD, CA. So it can be represented in terms of ordered pairs also, that is A, B, C, D, C, A. So now to find the directed edge, I'll be taking two vertices of a digraph. That is a vertex from which it begins and the vertex which it ends. So those kind of edges will be called as in directed edges. For example, if AB is a directed edge of a digraph, then it is understood that this directed edge begins at the vertex A of the digraph D and terminates at the vertex B of digraph D. So here the starting vertex, the vertex A will be called as an initial vertex and the B will be called as a terminal vertex. So in simple way means the starting point of an edge will be called as an initial vertex and the ending point of an edge will be called as a terminal vertex. We can take one more example also. We can see here the figure 2 consisting of only one vertex having two edges here. Similarly, the figure 3 consisting of two vertices with two edges. Figure 4 consisting of two vertices with three edges. So in this example, the figure 2 indicates a directed loop. Which begins and ends at the vertex A. The initial vertex and the terminal vertex of a particular edge is same means we will be calling it as a directed loop. In the figure 3, we can observe that two directed edges having the same initial vertex and the same terminal vertex. So those kind of edges will be called as a parallel directed edges. And the figure 4 indicates that two or more directed edges having same initial vertex and same terminal vertex. So those kind of edges will be called as a multiple directed edges. So now a vertex of a digraph which is neither an initial vertex nor a terminal vertex of any directed edge will be called as an isolated vertex of the digraph. In simple way means a vertex with no edges will be called as an isolated vertex. So now I'll be discussing about source and sink, like what is source, what is sink. And non-isolated vertex, it means that it contains some edges. A non-isolated vertex which is not a terminal vertex for any direct edge will be called as a source. Similarly, a non-isolated vertex which is not an initial vertex for any directed edge will be called as a sink. It means that no ending point for a particular edge will be called as a source. The starting point for a directed edge will be called as a sink here. For example, we can see in this figure, this graph contains 6 vertices: v1, v2, v3, v4, v5, v6. So in this figure, the vertex v4 not having any edges, so it is nothing but v4 is an isolated vertex. And we can observe at the vertex v2 no outgoing point here. I mean, the no initial vertex is present at the vertex v2. So this kind of vertex will be called as a sink. Similarly, at v1 and v3, no incoming vertices. So these kind of vertices will be called as a source. In degree and out degree of the graph. For example, the in degree of the vertex v in a digraph is the number of edges ending at it. Will be called as an in degree of the vertex v. It is denoted by the notation in degree of v. So in simple way means the number of edges coming towards a particular vertex will be called as an in degree of the vertex. The out degree of the vertex v is of a direct graph is the number of edges beginning from it. Will be called as an out degree of the vertex v. It is denoted by the notation out degree of v. In simple way means the number of edges moving from the initial vertex will be called as an out degree of the particular vertex v. So now we will see how to find the in degrees and out degrees for the example. The problem number 1 is find the in degree and out degree of the vertices of the digraph shown in figure. So this digraph consisting of 6 vertices v1, v2, v3, v6, v5 and v4. So here v1, v2, v6, v5 containing multiple edges, v3 contain a loop and v4 is an isolated vertex. So now I will be telling about in degrees and out degrees of the particular vertex. At v1 we can see only one incoming edge is there, so we'll be having the in degree is equal to 1 and 2 edges are moving from the vertex v1. So we'll be having here 2 out degrees at the vertex v1. Similarly at v2, one edge is moving from the vertex v2. So the out degree will be equal to 1 here, and 2 edges are moving towards the vertex v2. So we'll be having 3 in degrees at this vertex. Now at v3, the loop is there. So I mean the in degree will be equal, the out degree will be equal to 1 here, and the in degree will be equal to 2. And at vertex v4, no in degrees and no out degrees because it's an isolated vertex. So here no edges. So no edges means we cannot find the in degrees and out degrees. At vertex v5, we can see that 2 edges are moving away from this. So we'll be having here 2 out degrees. And 1 edge is moving towards the v5. So we'll be having 1 in degree here. So at v6, 1 in degree we are having and 1 out degree we are having. The same thing can be expressed in the tabular column also. So the vertices of the given graph, that is v1, v2, v3, v4, v5, v6 in degrees. At v1 is 1, at v2 is 3, at v3 is 2, at v4 is 0, at v5 is 1, at v6 is 1. The number of out degrees at v1 is 2, at v2 is 1, at v3 is 1, at v4 is 0, at v5 is 2, at v6 is 2. One more example, find the in degree and out degree of the vertices of the digraph shown in figure. So this figure consisting of 7 vertices v1, v2, v3, v4, v5, v6 and v7. So here v2 and v3 consisting of multiple edges. So now at v1 no in degrees. So the 4 edges are moving away from the v1. So we'll be having the out degree is equal to 4, in degree is equal to 0. At the vertex v2, only 1 degree is 1 in degree and 2 out degrees we are having. At vertex v3 we are having 2 in degrees and 2 out degrees. At vertex v4 we are having 1 out degree, 2 in degrees. At vertex v5 we are having 2 out degrees and 1 in degree. At vertex v6 we are having 2 in degrees, 0 out degrees. At vertex v7 we are having 4 in degrees and 0 out degrees. The same thing can be explained in tabular column like this. So the number of in degrees at the given vertices v1 is 0, v2 is 1, v3 is 2, V4 is 2, V5 is 1, V6 is 2, V7 is 4. The number of out degrees at V1 is 4, V2 is 2, V3 is 2, V4 is 1, V5 is 3, V6 is 0, V7 is 0. So next is definition of the graph. So this graph can be denoted by the notation capital G. It contains vertices and edges. So to say this G is a graph, we have to satisfy two components. The first component is the G must contain finite set of vertices, are also called points or nodes, and it must contain finite set of directed edges E. So this edge is also called lines or axes connecting a pair of vertices. So now a graph or digraph containing no edges will be called as a null graph. I mean only vertex will be there, no lines, no axes connecting the vertices. So those kind of graph will be called as a null graph. A null graph with only one vertex will be called as a trivial graph. A graph with only one vertex will be called a trivial graph. Next one, order and size of the graph. Like how to identify the order of the graph and size of the graph. For example, the number of vertices in a finite graph will be called as an order of the graph. For example, a graph consisting of 6 vertices, therefore the order of the graph will be equal to 6. Now the number of edges in a finite graph will be called as a size of the graph. Okay, to find the size of some graph. So the graph having 6 edges, so we'll be having the size of the particular graph will be equal to 6. So in other words, we can say that the graph G is equal to V comma E. The cardinality of the set V, it can be denoted with the notation modulus of V will be called as an order of the graph G, and the cardinality of the set E, denoted with the notation capital E, will be called as an size of the graph G. A graph of order n and size m is called n comma m graph. A null graph with n vertices and 0 edges will be called as an n comma 0 graph. So now I'll see how to find the n vertices, loop and multiple edges. Okay, so I'll be taking a graph and I'll be denoting the vertices of the graph with ABC, or we can denote it as V1, V2, V3, etc. And the edges of this particular graph can be denoted with E1, E2, E3 and so on. For example, if Vi and Vj denote two vertices of the given graph, and if Ek denotes the edge joining this Vi and Vj, then this Vi and Vj are called the end vertices or end points of the particular edge Ek. So this can be denoted as Ek is equal to Vi comma Vj or Vi into Vj. So now a single edge is connected to single vertex will be called as a loop. I mean the initial vertex and the terminal vertex of a particular edge is same, will be called as a loop. It is denoted by Ek is equal to Vi comma Vi. Now a graph having two or more edges having the same end vertices will be called as an multiple edges. So now simple graph, multi-graph and general graph. A graph which has neither loops nor multiple edges. I mean a graph consisting of no loops only, no multiple edges. So those kind of graph will be called as a simple graph. Now a graph which contains multiple edges but no loops will be called as a multi-graph. A graph which contains multiple edges or loops or both will be called as a general graph. So for example, the figure 9 indicates a simple graph because it not contain any loops, any multiple edges, and figure 8 shows that it's a multi-graph because it contains multiple edges here. Thank you.